Okay, it's streaming now.
Amazing. Do I have to leave it open or whatever? Anyway, okay. For all the people in the Zoom, sorry I have to restart. But I'll do it very fast. Hello, welcome to the 52nd edition of Talk.CSS. Twitter is SingaporeCSS. Hashtag is Talk.CSS. Website is SingaporeCSS what?
You got to close that window.
Close which window?
The YouTube.
Oh, 那个有录音啊。So I shut it off, huh? What? Can I read or not? Can I?
Okay.
Can I?
Carry on.
Oh, okay. The technical guru say carry on. Okay, got code of conduct. Don't harass anybody. Akong will come back and find you. Yes. Election coming. Don't do funny things. Moving on. Shout out engineers.sg for tolerating our lack of technical expertise after 4 years. Still don't know how to press go live. Oh my god. Apparently Cheon said he will show up, but because I cannot see who is in the YouTube live chat, so I don't know if Cheon show up. But if Cheon show up, everybody say hi to Cheon because Cheon is Sweat King of Singapore. And the stickers, the very first stickers that Singapore CSS ever had printed by Mr. Lim. So when you see Mr. Lim, only say good things to him. Correct. Moving on. We have friends. Our sister meetup, Singapore JS, is probably gonna happen like middle of the month because we have a courteous schedule where we do not clash with each other. Our other best friend meetup is React Knowledgeable, who will be streaming on Friday. FYI, our grandmaster Shifu will be speaking at React Knowledgeable, so you must tune in because because it's React Knowledgeable number 80. Excellent. Host of the month is the interwebs because COVID is still alive. Let's not talk about it. So depressing. Okay, welcome to my favorite section. Favorite section of this useless intro. CSS color of the month, as you can see, is a very deep shade of blue. This blue is called medium blue. The reason why we chose medium blue is because I must show the reasoning behind our choice of color. This is as close a shade of color as we can find to PM Lee's magical blue shirt. If you squint very hard, it kind of looks like medium blue. Yes, so we are paying homage to PM Lee and his beautiful blue shirt. Let's talk about medium blue. In fact, let's talk about blue. Blue is one of the primary colors, regardless of whether you're thinking about it from light or from pain. Blue, it is the B in RGB, and it is between 440 to 490 nm on the visible portion of the electromagnetic spectrum. Now, medium blue is less blue than blue, because blue makes up 255. As you can see the number on my screen, the RGBA value for medium blue is only 205. So it has less blue than blue. If you think in RGB, that's like 50 units less. If you think in HSV, then it's 20% less blue. Everything else maintain the same though. Color of the month is medium blue. So medium, right, if you think about it, right, medium is like a descriptor. So we need to talk about this thing called ISCC NBS. It is 7 letters, so it's actually the same cadence as KNNBCCB, but not all of you know what it means. So those of you who know, just keep it to yourself. Anyway, this system is a color naming system, and it's very logical because it's based on 12 color terms and a bunch of modifiers. So the modifiers is things like vivid, moderate, brilliant, strong, deep, very deep, very light, very pale. Medium blue equivalent on this ISCC NBS system is vivid blue, because why not? Yes, medium blue, everybody, in homage of PM Lee. Today's agenda is me talking about HTML and CSS, and then we have a very long title. 重点 here is Bezier curves, which will be covered by our mathematically inclined friend, Gao Wei, who is we have many mathematically inclined friends Murray, who I'm not sure if he's watching or not, but shout out to Murray as well, who is also our very heavily mathematically inclined friend. But before that, of course, we must go on to the section that I forced everybody to listen to. So we shall open GitHub, which I do every month, whether live or online, because clearly I don't know how to pre-open tabs beforehand. Lol. Scroll. Okay, I will zoom because why not? Big text is nice text. Today is the 1st of July. I believe that Firefox 76 was released, stable release was yesterday or something like that. So if you have updated, you should have seen the congratulations, you're now on the latest version of Firefox, which is 78. So what shipped in 78? If you have been tuning in for the most of 2020, almost every month we talk about ease and where, because I think actually all the browser vendors seem to have coordinated quite well. The Chrome people are like, yeah, ease and where, so cool. Safari also made a bunch of announcements called WWDC recently. We'll talk about it later. So it seems to be a pretty coordinated release in terms of support of ease and where. In case you forgot, ease and where they are pseudo selectors. So you have more powerful logic you can put into selectors. The only difference between ease and where is that where does not affect specificity. Okay, we can talk a bit more when we talk about Safari later, because people WWDC made a lot of announcements. Another thing that was supported, released in 78 for Firefox is read-only and write-only pseudo class. So actually there are a lot of pseudo classes that I would say not that many people know about, because to be fair, it's new. And it's mostly for like form controls. So you can choose to style based on like form states, which is kind of nice. So I think required is a bit more commonly seen. You can do like required attribute on your form, and then when people try to submit, then cannot submit because they never fill in. So required optional, those are for the form fields. Valid, invalid are also UI pseudo classes. I think that we have seen in the wild so far. Less commonly seen in the wild is things like in range, out of range. This probably for the range selector. Enabled, disabled. Actually, that one also quite common lah. I think for the radio and checkbox, what is fun is there's this state called indeterminate. Not for radio, only for checkbox. So whereby like if you have a indeterminate state, usually is like if you want to select, it's like a nested. So this needs to use in conjunction a bit of JavaScript to kind of make it all make sense. But then it's like the minors, which is like, you check halfway, then they check everything, then they want called indeterminate. So you can actually style these specific states with CSS, which is quite nice. Safari technology preview. The last time I updated was 108. So a lot of bug fixes and things like that. And because I've been covering Safari TP regularly over the months, right? Actually, the what's new for web developers in Safari and WebKit when they announced during WWDC is just like a summary of what has happened so far. So if you click on the link, if you're actually looking at the screen and not like eating dinner, watching, I don't know, Chen Xingling and like listening to this because you're multitasking, the what's new for web developers, this one is a link to the WWDC video, which is actually quite good. The presentation is online presentation, but they're like code samples and everything. So I cover mostly the HTML, CSS bit. There's a lot of JavaScript and web API things also. So actually it's not that long, I think like half an hour now. So you can go and watch. There's HTTP 3, which is quite interesting. You can go and find out. I'm going to talk about this. Safari no longer supports Flash in 14, so that's another thing. Ease and where coming, support for image orientation. So if all this flying over your head, watch the video cause he got like demos and code sample inside. So not bad. What's new in DevTools? Chrome 85. There, as usual, a lot of like JavaScript enhancements. But the more, I guess the only tangentially related to CSS one is now you can edit styling for CSS in JS frameworks in Chrome 85, if that's your thing, I guess. There's also an article coming up from the Chromium team that talks about improving the browser compatibility this year, which is actually a very good thing. So like, everybody can worry a bit less about having like, work in one browser, don't work in another. Like personally, I just say like embrace it. It's like it's a feature, not a bug. But okay, can. Next point is new in Chrome. Okay, this one is due to popular demand from Mr. Jacob Tan. If you are on the live stream, I got remember leh. You see? Oh, hi, Jacob. I don't know. You can wash your hands in the live chat. Okay, you raise hand many times. Hello, Mr. Tan. Thanks for joining. Give face me. Translate to Chinese. So, what is CSS Overview? I'm very sure I shared my desktop and not just my window. So you all could see this is a copy of Chrome Canary because I like to live dangerously. So first of all, open DevTools. Ding 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 ding. And then actually I also can't remember go where. I think go settings, right? No. You go to settings and then you got this like nice navigation. A bit big. Why like that? Why cannot zoom up? Oh no, it's like Hotel California. You cannot leave. Anyway, experiments. So you go to experiments and then you click on CSS Overview. Then don't you save, right? It should just work, I think. And then I have to try to restart. Okay, let's try restart and see if this works. Because clearly I never prepared beforehand. Then 自己 anyhowly. Yeah, got already. Yeah, okay, restart your browser after you turn on experiments. So if you go to CSS Overview, capture CSS Overview. Yeah. Anyway, I'm using this plugin for like the cats because the cats are quite cute. But I don't know how much HTML, CSS, and JavaScript is it on the plugin. So maybe it's not a best idea. Okay, let's cancel this and open my own Singapore CSS website and let's try this again. Capture Overview. It's so long one. Jacob, you got try before or not? Why like that? Throw Jacob under the bus. Lol. Okay, like in theory, you're supposed to see like a nice. Okay, let's assume this is not working. I go back and show you the actual how it's supposed to look like one. So look like this. So you should see like a summary of like, I got how many elements lah. Actually, my Singapore CSS page though not very big. I don't understand you scan so long. But anyway, you can see your colors, you can see style rules, media queries, etc. So it's like a CSS report for your website that Chrome do for you. Amazing. Oh, process damn long. Okay, anyway, we can come back to this at the later. Like I leave it on and I let it run. Okay, what else? Oh, this one quite controversial. Google confirmed experiment to remove full address from URL bar. I actually don't have that much of an opinion on this. Like, I would prefer having the full address. I think this experimental. So I actually also not very, I don't stare at the address bar like all the time. So I don't know whether it's still there or not. But you can opt out. So I think they're turning it on by default. And then for those of you, for security reasons with capital S or just like want to see the whole thing, then you can turn it on again, I guess. But it's an experiment lah, so not sure whether this will be a permanent thing because I think the Twitter's quite vocal opposition to this amongst the oppositions. So that's that. Last thing is Flow browser. Okay, Flow browser we mentioned a few times because it's actually the only not big three browser engine. So if you're in junior dev, I also got talk about browser engines during junior dev once about the fact that my opinion is that today, right, 20 years later, if you want to do a brand new browser engine from scratch, it's almost impossible unless you have an army of engineers. And a very army of engineers with a very specific skill set. Flow browser is quite interesting because they are not even looking to compete with the big three. They are actually trying to support a more narrow use case, which is, I think, set-top box. They want to optimize for a different clientele, let's put it that way. So they are a completely different browser engine. I don't think they're based off anyone. I guess they borrow concepts, but I believe, if I'm not wrong, it's written from scratch. But it's not open source, so nobody can see. But because they are a proprietary product, but they've been quite on about like giving updates about their process, and they are also, because they are so new, right? Their architecture is multi-threaded out the box, which is quite interesting because everybody else had to build off whatever they had. So there's a lot of refactoring if they want to move to multi-threading. Firefox, I believe, and Chrome are both actively working on migrating, but it's like you are trying to change engine when the airplane flying, so it's also quite challenging. So maybe for them it is quite good. First, from start you can go different architecture from the start, which is different. So actually what I want to talk about this thing called like acid test. Okay, and click in, then you can see it's quite cute. I think some of you must have seen the earlier versions of the acid test before, because yeah. So for background, right? Okay, you don't want to read the words, I just summarize. Web compatibility. This is the web platform test. They came out with this so-called acid test. So there've been 3 versions so far, but even version 3 was like written in 2008. So it's like it's not that updated, to be fair. First one is this is like the earliest version. Is like HTML4. So if you are a browser vendor, you test your browser on this. There's the correct one, pixel for pixel correct one, and then like at the time when last time people never like standardized properly, right? Then it won't look like that lah. So like things are like sengit that kind of thing, or like I don't know, border wrong, padding near C, things bleed into each other kind of thing. So I think today day and age everybody passed acid test number 1. Acid 2 is was more tricky to render lah, so to speak. So there's like interactivity also. So this is the reference rendering. So you have to compare it to this. You must hit this to pass 100% lah. And acid 3 is the so-called latest, but again 2008 is still like I don't know 12 years old, right? Acid 3, where's the test? Acid 3 different because acid 3 is like a bunch of sub-tests. So if you run it in Safari, in this one now running Firefox or Chrome, 97 is correct because they never update since 2008. So maximum points you can get today is 97. So 97 is like, oh, good job everybody. So that's acid the acid test. So I thought it's like quite interesting to kind of rehash history. Okay, go back. What else? Oh, specifications. The web platform contribution guide published very nice documentation if you are interested. So I thought like talking about the acid test quite relevant. I always talk about web standards. Then web standards is not very far away. Like everybody can contribute one, just people don't want to contribute. But like it's not. Is the barrier to entry. I think they've tried to make it as low as possible, try to make it more friendly. So now there's a very nicely written, docs and guides. See, step-by-step guide to fix a W3C bug. And then got like interview lah. It's not bad. So everybody look, they managed to snag WPC.guide. So I don't know how much they paid for this domain name because like 3 letters. But people actually invested money in getting more people to try to contribute back to the web platform. And I want to point everybody's attention to this amazing fave icon. What is it? The fave icon. Okay, I cannot zoom a fave icon, but like it is a rooster. Interesting choice of fave icon. I appreciate all kinds of creative fave icons. Fave icons are very important to life. If you all have realized I've been talking very slowly, it's because I'm dragging for time because my speaker never come. Okay, now I review 为什么慧晶今天讲话这么慢。Translate to English. This is why Hui Jing talk so slowly because I was dragging for time until my speaker showed up. If my speaker never showed up, then I'll just keep talking. You know what I mean? But anyway, on the specification side, nothing really much. Is a bunch of updates for editorial updates. So I think media query level 5 you also don't want to hear already. Every month also talk about media query level 5. And inline layout was updated multiple times this month. So I think they're actively working on the spec. So they're like doing like 3 times. Like, oh yeah, it's just like how I deployed my pull request today. Then realized that I keep missing shit. Then keep adding like one-liner commits. Who knows? So nothing much interesting. The one thing that actually I wanted to talk about a bit more as part of my drag for time strategy is this border rounding. So one of my friends happens to work at Gecko, and he does quite a lot. His Kang Tao is a lot of the rendering bits one. So he wrote quite. I used to like it when the browser engineers write about the back end, because he had to do like sub-pixel borders. So sub-pixel, right, is related to the whole, how to say my brain not working. It has to do with, you know, sub-pixel rendering. So the thing about this is that it's not very straightforward. The long and short of it is, if you want to render something very crispy, right? Unfortunately, all your display, all your screen is still like discrete. It's still based on pixel. No matter how, you know, dense your pixel is, right? It's still 1 pixel. So there's definitely you cannot shrink until minimum. 怎样, no matter how, also need to have like 1 pixel. So now, when you have a very, very, very tiny border, like 0.01, right? Never mind, because you will definitely round up to 1. So round up to 1 device pixel, quite straightforward. Everybody agrees, okay, we do it at computed value, no problem. Layout, algorithms, perfect. The problem is when you have a slightly larger value, like here his use case is 10.5. So 10.5 is like big, not big, small, not small, right? So then end up when you have a 1.5 device pixels, right, you have to do anti-aliasing, which is like to smoothen out the sharp pixely bits. So now this is where the issue comes about, because Gecko, WebKit, and Blink, all of them have their two opposing views, and there's no good solution. So like you're just picking which, like, both also got good, both also got bad. So what he did was that he went with, he patched it, but like before that, WebKit and Firefox would do would round during compute time. So the bug that was raised was that, hey, how come my border smaller than what I thought it would be? Blink doesn't do that. Blink uses another approach, but Blink's approach actually causes other issues that are not within the scope of the original bug. Anyway, his conclusion is there are no perfect solution. It's a very short article, so I actually suggest just go and read it. It's quite interesting one. Like, always fun to see how other people do stuff. Constantly side glancing because I don't know whether he's done or not. But anyway, I still got more things to talk about. We must shout out the articles all very interesting, so can read or subscribe to the newsletter. Yo, okay, highlight 2 demos because one of them is by Olivia. So anything that is local, I will highlight. Olivia does it again. Amazing. So yeah, cactus. So amazing. Everybody, please go and hit the heart button. See, I can demonstrate. I show you how to hit the heart button. This other one, this is by, okay. It's not showing up correctly because I never turn on the flag. Okay, we go to Chrome. Our venerable Mr. Lim Cheon made a very tokong backdrop filter demo. So yeah, can view. They're like, oh hi, oh look, backdrop filter drop shadow. Oh my god, yay! Everybody, please hit the heart button on that also. Amazing. Moving on. Y'all can keep testing. I got a lot of shit to talk about. Okay, today's theme is Bezier curves. So are you done, or do you want me to continue Gonggosu, or do you want to Gonggosu together with me?
Yeah, I'll join your chat.
Okay, amazing.
Zoom meeting.
Okay, you own self OT join Zoom meeting first. I can start to Gonggosu. Gonggosu translate to English means tell story. Okay, let's see. This one I got prepare, okay. 不要看我 anyhow. So Some of you may or may not have heard of Bezier curves in your life. Maybe your math teacher got tell you, maybe your math teacher never. I will try to set some context on why it's relevant to CSS because it is. Today, we want to talk about the history of CSS animations. So, everybody, you can take a look at my meticulously crafted notes that I actually just put together before I siapan today. So actually, it's quite anyhowly. But hello, everybody. We will talk about this together. So the first transition working draft was published in 20th March. Okay, the reason I put everything there because I need to click links. So okay, when you look at old specs, right, you have to have the date there. Because this is like the snapshot. If you do the without all the date one, you just go to the latest one, so you can see all the exciting bits. So they'll tell you it's outdated lah. They'll just remind you, hey bro, this is like everybody, you cannot keep saying bro, but like this version is outdated. But this was the first one, published 2009. So this was animation actually quite new. When CSS, even until CSS2 don't have. So somebody was like, yeah, let's be able to transition smoothly. So the abstract is very is one sentence. That's the best abstract. Can you distill the essence to one sentence? CSS transitions came up first. Yes, both specs actually released at the same time. So like you look at the date, right? It's also 20th March. This is because you have to have the transition first. Animation is extension of transition. So animation and abstract also very tokong. One sentence. Allow author to modify CSS property values over time. Da-ding! Amazing. So yeah, at the time 2009, they wanted to introduce this to let people animate transit. And the math starts from here because at the end of the day, right, what is a transition? A transition is you need to change the value of your CSS property smoothly over time. So got number means got maths law. So at the time, SVG already can animate, but at the time CSS don't have. But because SVG and CSS people are friends, there's a SVG and CSS effects task force. Click link. So this is the task force, and then it's actually a very quite cool. Y'all can subscribe. It's a public mailing list. So it's like public-fx. So how W3C works is that until now it's still very old school. Like it still goes by the mailing list style of interaction and communication. And what's fun about this is that you can everything recorded so you can go back and see all the discussion. Very nice one. So Rachel Neighbors, I think the children, all your children nowadays, you'll probably know her as the person who write the React Native docs. But way before that. Actually, no, like we are quite similar in age. She was an award-winning cartoonist and animator, and a lot of web animation stuff, cause it's because of her involvement. So let's go back to 5 years ago. 5 years ago, 5 years ago, Rachel Neighbors posted a suggestion in this FX mailing list. In her travels around web animation, the community, like the animators, they want, because animators are quite, how should I say, they would like to fine tune their animations the best they can, right? So okay, I think I should zoom this a bit. So she was like, can we have more powerful timing function, because like 2 coordinates like not very fun, you know what I mean? So she says, yeah. Everybody look, okay, I want to point everyone's attention to the date. 11 August. Okay, 11 August. And then immediately, same day response by Amelia Bellamy Royce. She's also like, she's been the as far as I know, she's been in the CSS working group forever lah. Same day, just like few hours later, people already got proposal for the come up with the explanation, then the proposed spec, then proposed property value, then propose more things, and then Yeah, within 3 hours. So this is efficiency, everybody. This is how actually this is also a peek into how a spec potentially comes about lah. So basically, and the maths part of it will be explained in more detail by my mathematically inclined speaker. But the transition timing function takes a number of values that like most of us have used before, like is in, is out. By default, you don't know how to do, then you just put is. Nobody put linear one for some weird reason. But there's also one value for cubic Bezier. Then cubic Bezier, you will take 4 value, which is for two coordinates. Just like the most basic of basicness. Then people say, yeah, these 2 basic already. So actually her proposal was like, can we have like more complicated Bezier functions, which will be covered in my mathematically inclined speaker's talk. So that's that. And so then it like, then it trail off lah, because it's a bit, it's very initial stages. So 1 year later, what did WebKit do? WebKit implemented, WebKit proposed this function called the Spring function in 2016. So we should all look at the Spring function. It only works in, it looks like it works here, but this is fake. This is like fallback by JavaScript one. But if we want to look at the real one, right? Okay, everybody, install Safari Technology Preview, like the developer you should be. Anyway, okay, everybody can watch this. Click on Use System Spring, just to prove to everybody that is legit. Canvas object. There's no exclamation mark, everybody. This one, your browser say, oh, hi, I know what Spring is. Spring is a timing function that is legit. If you try this on Safari, right, Safari will tell you, sorry, I don't recognize. So must be Safari Technology Preview, everybody. So yeah, so if you drag this cute little ball, right, you're like, toing. So the toing thing, right, is Spring lah. But like, so by then, right, this is 2016. This is like story time. Sorry, I'm eating a lot of time. So Spring, right? Spring very specific. Spring can only Spring, right? Spring can toing. Then you want to do other things, how? So it was like revitalized again. Whereby, so Rachel Neighbors chimed in again to say that Spring, that's great, but this would have been solved with the support for more complicated Bezier curve function, right? So if I can open the never, they're not linked to the thread. Okay, no, here. So this again, publicly available information, everybody. You go to GitHub, you go to W3C organization, then you go to scroll. CSS working group draft. So there's like 1,849 issues. Of course, because all the discussion going there, people got name spacing. So you look at the correct tag, easing tag. Anyway, this is the problem in 2006. Go on. What was I going to say? I'm going to say something. Yeah, okay. So over time, right, there are a few other things that are related to animation. There's Web Animation API, which is the JavaScript side one, which is mostly spearheaded by a guy called Brian Bertels. Then there are the guys working on Houdini, which also that's another vector in it, because you could implement this type of like custom functions, use Houdini, expose and do. So okay, I have to take care of that also. And then there's also the existing, your new proposal, right? You need to sit nicely with what already is available, like keyframes and like the rest of the CSS syntax. Mathematical sweet spot. Wait, I saw this earlier, but really?
Yeah, previous one.
Correct. So I read this whole thing, but I never bookmark. Basically, they are saying the basic one, too basic, and then the to the power above the power of 4 or 5 one is too complicated. So they are like, oh yeah, cubic Bezier. Polynomial is the solution, but cubic Bezier is the mathematical sweet spot. So Sarah Dressner actually opened another issue. Sarah Dressner, you should know already, but if you don't know, right, she is probably unofficial ambassador for Vue. Also like Netlify, dev advocate manager, whatever. Everybody knows her for her amazing Vue articles and amazing animations. So she actually talk about replacing Panner's easing function. So Panner, every easing function you use, almost every easing function you use, like in programming today, right, is based off this guy's original functions. His name is Robert Penner. He released this book 2002 for Flash, and then it has since been like, you know, translated in and implemented into a lot of libraries, animation libraries. Most of the time, if you have an easing library, it's underlying it is his easing function. So like just now was saying like, hey, can we replace the Penner's easing functions to support more better physics, you know what I mean? So they're like, oh yeah, cool. We have this discussion, issue 229, we just fold everything in. So now that issue is like, wow, long. Yeah. Have you ever seen an issue that lasts for like, I don't know, 4 years? Don't have, right? CSS working group. Anyway, so it got revitalized again last year. And it's actually very nice because it's a lot more detail now. There's like nice diagrams and everything. But the long story short is today still don't have complex Bezier timing function, not implemented yet, because it has since moved a few specs. It has now moved into its own spec called CSS easing. It's called CSS easing function. Then and not just CSS easing function. They some more defer it one more time to CSS easing function layer 2, because you know, very hard to estimate timeline of work. Yeah, okay, like I said, okay, she had like clearly has showed up already. So you should share your screen.
Yeah, let me share mine.
Now that I have set the context on how Bezier curves are related to CSS,
I
and
think
if
I
you all
cannot
haven't fallen asleep
share
yet,
it now.
you cannot share now. You
Says only host can share.
in the meantime, while she magically gains permission to share her slides, we can continue to talk more nonsense about specs. Okay, so look at this lovely diagram.
That's a spline.
You probably turn off the virtual background.
Tak. Okay, actually there's no point camouflaging already. We have like, you know, that ship has sailed. 要被包兜就是被包兜了。don't 包兜 us
I think I
躲高笼。
still cannot share.
Which one are you using? React knowledgeable?
Yeah, React knowledgeable.
Okay.
Sorry,
Sorry,
I'm using that one.
Put
to
wrong person in. None. Okay, everybody knows where we are already. Oh well.
You should go share.
share. Yeah.
Okay, I'm gonna start sharing and then let the actual professional talk about Bezier curves. Tell this nonsense. Okay, go. I can't see anything.
I think I can see. Wait, is it not? Can you see my screen now?
You got share screen or not?
Yeah, I got share screen.
Mana de.
No? No, man. Let me stop and do this again.
Welcome to the world of technical difficulties, everybody.
Stop.
Oh, I got chat. Okay,
Is
let's
it,
see.
Is it showing up?
React knowledgeable has started share screen share.
Okay, got time lag.
Oh, okay.
Jacob say reload browser. I did and it's super fast. Okay lah. Jacob, you win.
Well, great that you have supplied the CSS.
Are you sharing now?
Yes, I am sharing now.
No combo, look at wo.
Just a black screen though.
Damn.
Eh,
You,
Is it?
can you just transition to another slide or something?
I think I am transitioning.
First can see but yeah,
Hello?
okay.
Really?
Why like that? My excuse is I don't use Zoom at work, I use Google Hangouts. No.
Interesting.
Okay.
Okay.
But Zoom recognize that she's share screen.
Yeah.
no,
Okay,
no.
let me do this again. Okay.
We are doing
Right.
everybody's solution to all of the world's tech problems, which is to turn it off and turn it on again.
Let me try this
Everybody
again.
must send us positive
Screen.
thoughts.
I'm using this because I need to draw.
Yeah, I know.
Yeah.
But
Oh, yeah.
无聊. Everybody remember, if it doesn't work, turn it off and on again. Okay, 来,
Is it showing up? Is this page showing up?
got time lag lah.
Is my slides showing up?
We are lagging, right?
Is this about lag?
Are you? Okay.
Got
okay.
it.
Yeah.
It's a bit
Oh,
lag. It's
okay.
lag gao
Okay.
gao.
Can
Yeah, showing watermelon. Okay.
right? Okay. Watermelon is like I feel like previously I feel that Bezier curves is like
Actually, I want to ask you about this. What does Bezier curve have to do with watermelon? Chinese called 西瓜.
Because you know the meme about 吃瓜群众.
Don't know leh.
Yeah, so in Chinese, if you say you're like 吃瓜群众, basically means you have not much to do with this, but you are still participating, to be somewhat relevant. So it's because like Bezier Curve is not exactly CSS. It's like
I already debunked that myth. Anyway, if this was a variety show, right, you would see the editor put like 3 question marks on top of my head for the Sigua thing. But never mind. Today you not only learn CSS, not only learn maths, you also learn Chinese. Wait.
Chinese meme, not really real Chinese.
Okay, mystery of the watermelon solved. So let's explain Bezier curves to computer engineer friends. I'm technically not a computer engineer, so okay, you can explain it to Shifu sitting opposite us, who is a computer engineer.
You're an engineer now. Yeah, you're an engineer now.
That's not my role. But anyway, moving on.
Yeah. So it all begins when we try to have some kind of natural animation.
Or like the spring, huh? Point.
Yeah, the spring is new to me actually, but
it's a very cold storage. It's a very cold storage function because only TP got. So they're like testing like, I think they tried to push then it's like fail. Then they're like, I'm not taking it out. So it's still there.
Right. Oh well. So okay, let's see if this loads. This is Google Material Design, design language, and
my opinions to myself.
It has this. Why doesn't it load?
Why not Wi-Fi? Not on the hackerspace.com Wi-Fi.
I thought 4G is okay. Then okay, let me connect to
everybody. This is how a professional presents. People use iPad. Not like us, huh?
Right,
use like
on Wi-Fi.
Type on a keyboard and then use 2 fingers to type. Then like cannot even open a web page.
Okay.
Lol.
So if you can see this animation, it has 2 side-by-side comparison. There's one with easing and the other one is like linear.
Why never highlight?
Never highlight.
Why so dark?
Yeah, interesting.
No, it's Google problem. It's not your problem. It's Google problem.
So if you see the no easing one, it's kind of moving like steadily, but it doesn't feel as natural. But the one with the easing kind of has a natural take. And then there are different types of easing, like like this one kind of looks like you're throwing a toast like up to your screen, and then there will be one that's like looks like things dropping, like that, right? So so how does,
now then become bright. I'm so confused. But anyway,
so how does like a curve do that? So disconnected. Oh right, okay. It's not updating. Right, okay.
Must be patient.
Fine, okay. So if we are to implement this like without the help of easing function, right? We do have another option. Like we can have, this is divided into 10 frames, and then for each frame you can like punch in a number, and maybe you
actually this is what I do. I legit do this for. I actually did this very recently. I just can't remember what I did for. Okay. But
it's okay. Well,
we show later. Show later.
Okay.
Yeah. Please carry on. But like keyframe, this is and what I do is I eyeball it. I don't really eyeball it. Like in my mind, I just like imagine. So I did 0 to 10, and then 10 to 40, 40, 50, then 50 up 90, 100. You know what I mean? That's like
yeah, exactly. That's what you can do. And if you want to be more precise, maybe you can do some like physics calculation to evaluate like how much the thing dropped.
At my age, I'm like weighing the pros and cons. I'm like my youth physics calculation. My youth physics, never mind. So yes.
Yeah,
please.
So that's like your alternative.
Tell us what the best scenario is.
well, anyway, here we have like 10 frames, but you can do better. You can do like 100 frames.
Do better. Okay, 10. Moving on.
but then if you have this magic cubic Bezier curve, right? There are some default ones. These are like shortcuts of the actual the actual Bezier curves. But what you have now is you have this magic number, and then actually you do not have to understand what is really going on with the Bezier curve.
Don't tell them that. You must say must understand.
Okay, I think
pretend you're not here.
I think my iPad cannot drag and drop this thing. But anyway,
no, you be more precise lah. Use your $100 stylus.
It's not about the pencil. Like it's more about like the iPad like interaction, right? Anyway, so you
I was gonna say something very snarky. When things go wrong, blame it on the machine. Anyway,
but you have the option of this. You can drag around, and you can see what this curve looks like, and then the y-axis will be the displacement. So where your moving object is, and then the x-axis will be the time. So if we look at like this curve, right, it looks like it's moving kind of slowly in the beginning, and then as it moves, it gets a bit faster, and then it slows down again. So that's what this curve tells us. Like geometrically, we can do everything, and like our so if you look at the actual animation that is happening, you can test.
I prefer to have this with sound. Can someone please do like use wavelength, and then you can like then I can it's easier for me to understand. I need to hear. Anyway.
That's a nice one. But anyway, that's
somebody's
why
side project.
That's why like our designers actually can give us very specific those numbers, and we just punch those in, like copy those in our code base, and then we have their desired animation. Before we really talk about Bezier curve, we know our end goal. We have those like only like 4 numbers, and somehow we get
2 coordinate. Correct.
Yeah. So okay, getting back to the Bezier curves.
Patience.
Okay. Yes. Wait, why is this?
Remember, if things go wrong, blame it on the machine. I don't know what's going on.
Reload. Okay.
Amazing.
Slides.com. Please sync this better. Yeah.
Oh,
so
shots fired.
So how does it like really work? Like why a few numbers can represent a curve, right?
Amazing.
So it turns out we are actually not learning from our peer computer engineers. We're learning from our senpais from like 50 years ago who are automobile engineers. So
specifically French automobile engineers.
Everybody,
do y'all know how to pronounce Peugeot? It's not Peugeot lah.
I actually don't know it. I did not do the research.
Peugeot, I think.
Peugeot.
I think it's Peugeot.
Right. So this is this car was the first car that was built using this Unisurf CAD. CAD is computer aided.
Yeah, computer aided design.
So this new system, which was devised by this gentleman,
handsome gentleman,
Pierre Bézier. I like how the illustrator put like
everybody is Bezier, not Bezier, Bezier, y'all don't, y'all learn the right thing. Cause even though every day I speak English, if I really want to, I can pronounce things correctly one. So Bezier.
Yeah. So
not
there's a control point there, apparently. Kind of cute. So Bezier, back then he was working at what was the car company again?
Renault.
Oh, Renault.
Renault.
Renault and Citroën.
Everybody.
Was
but in case you all don't know what we're actually talking about, let me give you the Singapore pronunciation. Renault and Citroën.
Okay, can. So back then he was working on...
Must translate. Singapore CSS.
Research and development. and he was trying to find a way to model curves, and he was also trying to push forward some like research funding within the company, but didn't get much support from the company. But he did it anyway. I'm guessing on his own initiatives.
I feel there's a story to it. If your boss say cannot do, right, just do it anyway.
That kind of sounds familiar.
Yeah, I know. Right?
Yeah. So so he was trying to model curves in the car design process, and it turns out like modeling curve is not so easy.
You think?
Yeah. Why is? Oh yeah. Okay. So let's see. So there are multiple attempts, like not necessarily in that period, but there are multiple attempts. They can seem a bit weird, but those are all legit attempts. Like, for example, in this diagram shown here, you have like you're trying to devise an elliptic curve by attaching a circular curve to like a to a square, and then those those frame is you can squeeze that into a parallelogram, and at the same time the curve gets the shape gets changed, so you get a new curve that looks like that. Here's another way. So
this one look more takong.
Yeah, this
one got projection.
This one looks more relevant to the car industry. So maybe they did this attempt. So you have what you do is you have some shape that you you create first, and then you put a projector, put a torchlight actually behind the shape you get, and then you project the curve onto a wall. And then you kind of note down precisely where each point is. So that's another way. Well, it doesn't seem so smart if we look back, but
hindsight is 2020, my friends.
Yeah, but
yes.
Before we have this, like, now we know how to do this, or now we know one method how to do this. But before we really come up with this method, like all the attempts are like not as trivial as we might think today. Here's another one. I'm not quite sure how this one works. It's also coming from.
I don't understand the diagram.
So so you have a few springs, and then you attach strings that go through.
Is the string supposed to be the curve?
Yeah.
Like that also can walao.
I actually don't know how you can actually like note down.
Yeah, I'm like, what's wrong with using a pencil? But okay, never mind. Do not question the wisdom of our predecessors.
I guess
I'm sure there's a good reason for this.
They can introduce some kind of variables like by using the spring. Like you can adjust like how far each of the string goes. The spring goes.
No, actually now it makes sense because you cannot keep redrawing. I mean you could, but it's like, okay, I kind of can imagine why already. Okay.
Yeah. So all
those
those
so smart last time.
Yeah. There are more approaches. These are only like a few examples of those.
Respect your elders, everybody.
Yeah, basically, well, it's not that easy. But then mathematicians say if you have a closed interval meaning like the interval but with the endpoints, and then if you have a smooth curve, continuous and smooth curve, you are guaranteed to have a polynomial function. It means it's a combination of x to the certain power with like some
this
coefficients.
Part I haven't given back my teacher. This one I got keep for 20 years.
Yeah. So you're guaranteed to have some kind of polynomial approximation. Don't read the Weierstrass theorem. It's like
you're just doing a pink elephant. Like, don't think about pink elephant, then everybody think about pink elephant. I'm sure people go and click one.
Yeah, so basically mathematicians say you're guaranteed to have one, but then engineers won't be satisfied with this. It's like how exactly
engineers are allergic to the word approximate.
Like how exactly, yeah. Yes, actually. Because I feel engineering is more like the balance between like perfect and
I would say
like,
precision.
precision, yeah.
Precision.
Yeah, most of the time the idea is you set like a
Threshold.
yeah, and then if it passes, then you're happy. But then still, for engineers or for actually make it usable, we need like a constructive way of actually doing this. So let's try to approach this modeling curve problem together. So I guess one intuitive way can be, it feels like cutting a wood board. So if we look at this curve, it's like cutting around the corner. So basically the curve will look like it comes out from like one side of like a rigid, like a rectangle, and it's trying to approach the other side of it. So here's I think this one comes from Wikipedia, no. But anyway, in other words, like this curve, if we try to intuitively imagine what it is doing, it's kind of trying to move towards so it starts from one point and tries to move towards the end point, but by doing by moving along these two lines at the same time. So you're moving along the first, like the shorter line, but then at the same time you're also moving along that direction. So how do you describe this behavior mathematically, right?
It looks like, it feels like gravity. It's like you are
exactly.
pulling in, or if you don't know, like vertical, because vertical very tired, you want to lie down, right? Imagine that like one person pull you this direction and then another person pull you in the other direction. You're not going to end up in either direction. You're just going to go like in between the two of them.
Yeah, actually, exactly. It's exactly like if you throw something out, the curve is a parabola. So how does that parabola form? Is like you have an initial force, initial velocity that goes like horizontally.
Yeah.
And then you have the
gravity that acts downwards.
that
Specifically, this use case doesn't work if you throw straight out, straight down. Everybody is like throw forward. Okay, like shortcut.
Actually, that one is also, it can be generalized to that, because if you throw up and it falls down.
But visually, you won't see it, ma.
Visual, yeah, you will see is the object.
You have to plot the velocity onto a graph to be able to visualize the curve. You know what I mean? Like in the physical world, the path you cannot see the path intuitively.
It's a bit harder for you to intuitively imagine that, but it's actually the same thing, because the initial velocity, we're used to thinking of it as a magnitude, but actually it comprises of a direction and a magnitude. So even if we're like throwing this, like if I'm throwing it that way, then the initial velocity is not necessarily completely horizontal.
Yes,
so it's
correct.
Like, it can go like, likely it will go like towards upper direction.
So basically, if you all got play MapleStory, or Gun, there was a Gun one. So there's this game, right? Last time I played secondary school, then like spend too much time on it. You go around bombing other people, and then you will have to like adjust the direction of your cannon, that one, right? Yeah, so it's like if y'all cannot understand what we're talking about, like what's this ball throwing, right? Just think back to your, like secondary school, then ask you study, don't study, then go and play game. Yeah. It's the same thing.
Yeah. So the throwing up is just another.
Basically, you trying to bomb yourself.
Yeah, special case of like throwing things like
without a horizontal like where the mouse. Okay, can.
Yeah. But then the actual physics is the same. Actually, you can draw that with the Bezier curve also.
Actually, physics makes more sense for me than maths. Just saying. I blame my father. Moving on.
Yeah. So anyway, in Wikipedia, you will get this beautiful GIF, I believe. So
amazing.
So here, what it does is you can see that this point is trying to move like towards these two directions at the same time, and that's actually exactly the approach of the Bezier curve.
A picture says 1,000 words. So if you're only listening to audio, sorry everybody. I'll ask you to look at screen.
So basically how we want to do this in a computer today, right? Like time travel, like 70 years later. Is it 70? Yeah, roughly. Is to try to figure out what is the coordinate of that black dot. So here is I'm gonna start drawing. So first of all, I want to share with you like how in a simple case, like how how we find the dot, the final dot with the. Okay, so
yeah,
let me just start drawing. I don't know what I'm talking about.
While she's drawing, right, I will entertain everybody with what Jacob has reviewed the game that I can't remember the name too. Gunbound. Everybody is called Gunbound. Yeah. Jacob, you just dated yourself. You're like almost same age as us on. Hey, old man. Just kidding, guys. As you.
Yeah. So basically, for a simple case, I'll just redraw the triangle, but maybe this triangle is
like draw your line as crooked as you can, and then like autocorrect straight line.
Right? Yeah. So let's say we're trying to find the Bezier, find the curve that goes roughly from this first point to the final point, and what we do is we try to depict this as a progression. So if we're talking about progression, we're talking about a number from 0 to 1. 0 meaning you haven't started, and 1 means you finished. Yeah. So so it goes from 0 to 1, and normally we call it T. Maybe that stands for time. So let's say that we want to find the 25% progression of this. What we do is we find the 25% of the first line first. This is not 25%. Let me use another color. Somewhere here. A bit too.
I'll keep my snarky opinion to myself. Kind of like they are squares.
Yeah. So you find your first line. No, first point on the first line, and then similarly you will need to find your
corresponding 25% on the other line.
I think this is not 25. I was
Everybody just use your imagination and imagine it's 25%. Okay, like
I think I got it reversed because I got it like.
Okay, yeah. Okay,
so,
that makes sense.
So these are both 25%.
She's epitomizing the mathematician mindset of approximation, everybody.
And then what you do is you connect these two dots.
Autocorrect.
Yes. Yeah. And you have a second line. Now we notice that we are getting rid of one line segment. And what you do next is just like a next generation. This is precisely the word that we're going to use later. So what you do again is you find the 25% on this line segment. So normally we don't call it 25%. We call it like 0.25 to be the T. So now this point is going to be on the curve, on the final curve, but the final curve consists of many points. It can consist of infinitely many points, but how you actually get the actual curve is, well, your manager is going to tell you like how many points we want to draw. Maybe not your manager, but your colleague is to, or you are going to decide like how.
Basically, the threshold is like how much approximation is acceptable.
So you draw many points, and then eventually you'll likely get a curve.
Oh, not bad. This one like got improvement from last time. So we watched this before. So like, hey, Fatu.
Yeah. So okay. So the idea is you find the progression. You define the
step.
Yeah. Yeah, you define the step, maybe 500 or 1,000, and for every one of those steps, you will have a corresponding like T value, and then for that T value, you try to find the point on the curve, and also as you can see here, like for any single T value, the progression you happen to have progressed on the curve is exactly the same. So on the first line segment, you are 25%, and on the second line segment, you are also 25%, and then you get your intermediate generation of the line, and then on that next generation of line, you
use it to find the next point,
yeah, you
right?
still use the 0.25 progression to find the actual. Yeah. So that's the rough idea. And it actually doesn't have to. So the two line segment is a relatively simple case, and so the next engineer we're gonna talk about is his name is Castillo.
Castelju. I find this easier to pronounce than Bezier, to be honest. But anyway, French. Everybody's French.
Bezier easier to pronounce.
Can.
Castelju's algorithm. so actually, Castelju, he is actually the first one to have discovered this method using a constructive approach. So he described the whole process in a procedural algorithm that he uses when he works for Citroën.
Oh, this one is the Citroën guy.
Yeah.
Oh, today I learned.
Yeah. But then Bezier is actually the one who formalized the notation of using the points.
So they were in competing companies now.
Back then they also
were. Okay,
or
anyway.
maybe in collaboration.
Actually, I don't know because automobile might be a bit more.
Maybe not formally collaborate, but back then their industry also like got a community. It's more like even though you might not.
I feel like you think they're like browser vendors where like people
probably
imagine that they're fighting, but because they're just everybody's just friends, right?
Yeah, they probably are friends with each other, and maybe that's why like Bezier knows about this and then formalized this.
I don't think it's that big a community. Like every else, right?
Because they're similar age also.
Maybe they were BFFs. Okay, just kidding. Moving on.
Yeah. So, but anyway, he devised this algorithm, and so let me just draw another graph to show you again like how it actually works.
Seriously, like if you are listening to audio, must watch videos, yeah. Like this is like
really someone calls in audio.
Who knows as a guy, someone like frying fish, then like I'll hear what's going on. You missing out half of the presentation. Yo.
So this time we use like
slightly live drawing.
Slightly more complex situation. We use 3 control points. So together with the initial point, we have 4 points.
I love this autocorrect.
I'm actually not sure.
Okay, good enough.
Yeah,
and then squint, it's a square.
To show like to be more precise, let's also give them coordinates. So I think this one will be 0 and 0. Let's just assume it's 0 and 0, and then this one will be 0. Let's say 4, just for ease of computation. And this one will be what 4.
4.
And then this one will be
4 0.
And then also for ease of calculation, let's just try to find the halfway point of what this curve eventually will be. So t will be 0.5. So what's our next
blue color?
Set of
blue color.
Okay,
because
which one?
Today is medium blue. This one.
Oh right, today is medium blue, right? I missed the beginning part.
Never mind, it's okay. We already paid homage to PM Lee.
Yeah, so that looks like our first one is a bit up.
Never mind.
Yeah.
Again, imagine.
And then this will be our second point. Then the midpoint supposed to be the midpoint, so everything should be like center. Yeah, you can control like
autocorrect technology, my friends.
So this will be our second set of points, and let's give them coordinates also. So the first one will be like 0, 2, and then second one will be 2 and 4. And this one will be 4 and 2. Okay, and then similarly, next generation. So we'll find the first point looks like will be here. And then
not bad.
Next
can
one
pass.
Here.
Approximately acceptable. Lol.
Yeah. And then the coordinates will be average of 0 and 2 will be 1, and then average of 2 and 4 will be 3. And this one will be 3 and 3. Notice how we're losing one segment each time, and therefore also losing 1 point. So eventually we will land on the final point. This is a coral, last one.
Yes.
Okay. So the final
Coral, correct.
Yeah, so the final point will be here, and then it's computable. The coordinate will be 2 and 3. Yeah. So this will be because we're left with 1 point, and then this will be the final point on the curve. And so we've only calculated one curve, 1 point. But if we do this likewise, like many times for many different t's, we'll get a curve. Oh, this is going to be challenging. We'll get a curve.
Whole hand.
Oh,
Art teacher say don't use move the whole arm. Yeah.
Can you do this?
I use my other hand. So wait, you want to connect from here, is it?
Yeah, you're starting from the end point to the. Oh, nice.
I move my wrist.
That's
Art
nice.
teacher say wrong.
That's
Okay,
nice.
never mind.
Yeah, so that's how you. This is how
curve autocorrect. Sadly.
Yeah, it would be nice if it does. Yeah, so yeah, this is how the Castillo algorithm works. And if you read into the books, you will see something called the triangular scheme. So what is that, right? So let's move this like. Let's move this a little away. So like I mentioned, we are we're recursively trying to find some points on your line segment. So what is really happening is, like, for the first set of points, we have been calling that generation. So that's the first set of points is the initial control points. So we have P
Gen 0, 0 index 0, everybody.
Just P0, P1, P2, and P3. And because we're computer engineers and mathematicians, we like to start with 0 instead of 1.
Zero index, everybody.
So we have P0, P1, P2, and P3. And because it's generation 0, we superscripted with like P0. So P1, P0 of 0, P1 of 0, P2 of 0, and P3 of 0. So how do we get the next generation? We decided it will be blue, and then this will be Gen 1. And so how did we get from generation 0 to generation 1? We did that. We find the first point. This one will be.
No in. Electronic also can run
Really?
in.
Serious?
Lol.
Seriously? Hey, what's going on?
Turn it off and on again. Pencil, battery.
No. It's 100%. What's happening? Oh, yeah. Got
Turn it off and on again,
Yeah,
everybody.
yeah. So P0 of the first generation, how we found that, it's a linear, it's a combination, it's actually a weighted combination of P0 and P1. But what is the weight, right?
Yeah.
So remember how, like,
wait, where did this come from?
Yeah, we use a halfway point, which is slightly inconvenient for explaining intuitively what it is. But actually, so how I perceive this is, right after it leaves the first point, the weight of the first point is nearly 100%. So that's when t is really small. So how we come up with this is, we're taking the first point and we're multiplying the first point with 1 minus t, I think. Not working? Oh, yeah. So we're multiplying the first one with 1 minus t, and then we're multiplying the second point with t. And that's how we.
Oh, okay. Now 记住.
Yeah, so that's how we get like P0 of first generation, right? And then and then likewise, we're using the same method to get like. Oh shit! Sorry, I OCD. Yeah, so this is P1 of the first generation. So this is P1 of 1. And so once again, we're multiplying the first point with 1 minus t. That's this point. And then and the second point, that's this point with t. And And then similarly for the third P2 of first generation. So we're multiplying the first one with 1 minus t, and then this one with t. Okay, so you can see how this goes. And how did we get the third generation point? Second generation, yeah, 0, 1, 0, 1, 2, yeah. We once again we take this one, and it will be multiplied by 1 minus t, and then this one by t, and then that's how we get P0 of 2. Then technology, great,
amazing.
Yeah, P and then T, right? And then finally we reach our
horror.
Yeah, we reach the final point. I know, wrong corner. Yeah, so the first one by 1 minus t, and then this one by t. So this will be the P3, which is the final point. So so now first of all,
this is orange, not coral, right?
Oh shit.
Never mind. I'm just saying.
Yeah, okay.
You OCD straightness, I OCD color. So yeah, whatever. This is why your friends, yo. Anyway.
Yeah, well, I don't know, not close enough, but anyway. Yeah, so we see a beautiful triangle here. That's how they name it, the triangular scheme. Yeah, triangular scheme.
Semantic
also,
naming, my friends.
Yeah, and also notice how to deduce the final point, all we need is the coordinate of the first 4 points, and then a bunch of t's and 1 minus t's multiplied together, and with a few like coefficients likely multiplied together. And it turns out that it turns out these are Pascal's triangle, or
ding ding
yeah.
ding. I'm the sound effects guy.
Yeah, so the Pascal triangle, you can Google it. I'm not going into detail here today.
Let's teach everybody how to spell Pascal. Pascal. Pascal.
If I remember correctly,
actually, I don't know how to pronounce his name. I don't know if it's Pascal or Pascal, or you know what I mean. I don't know. I really don't know.
I think he's also French.
Seriously? Oh, these French people.
Not sure. Haven't justified, but
it's okay. I'm partial to the French accent. It's fine. Carry on.
I just have an impression that he was French. So the Pascal's triangle gives you a quick or easy way to figure out what those coefficients are. Basically, you start with like 1, and then you get you start with 1, and then the next set of coefficients will be 1 and 1, and then 1, 2, 1, and then 1, 3, 3, 1. So these will be the coefficients you will get like multiplied in front of all the t's. But anyway, the point is, we only need the coordinates of the initial points, and then like with our engineering skills, we can punch in a bunch of t's, and then we can calculate the final point. So,
engineering skills, flex.
Yeah. So that's
triangular scheme, ladies and gentlemen.
That's the
Castelju's
algorithm and the triangular scheme, and there will be a pseudocode. So
zoom.
Can see?
Sorry, yeah. Done.
Yeah.
Can, very nice.
Yeah, okay.
Sweet.
So this is exactly what we just did. The draw curve pseudo. Actually, I think it probably be better named as draw point. Right?
Oh yeah, actually you're right. It's
yeah. So
segue. Our mathematically inclined friend Murray has shared with everybody who is not on Zoom but in YouTube. We must say Pascal triangle was actually known by I don't know 这什么名字家贤 whatever 11th century Chinese scholar, centuries before Pascal. Be proud to be Chinese, everybody.
Yeah, there is a Chinese counterpart to Pascal triangle. So in China, if you study like in elementary school, they tell you it's Yang Hui 三角, not Pascal triangle, but Yang Hui.
Who is Yang Hui?
I think Yang Hui is like Chinese
Like
mathematician.
it's 一个人的名字 like his
Yeah, yeah.
surname Yang 名叫会
Yeah,
杨辉
yeah,
right? It's
yeah.
just not like some random. Okay.
Yeah,
Good to
Yang
know.
Hui Sanjiang. So yeah, so this pattern basically multiplying a bunch of things with like factor them out, and the coefficients, I think people figure out the pattern without, I guess they haven't talked to each other. But
Math is universal. No language or cultural boundaries. Just saying.
yeah, so okay, back to the actual
segue over.
pseudocode. So the drop point, the function pseudocode, the input will be the points. Those points are the initial control points. These are the only information. This is the only
Information that you need.
coordinations that we need. And then we also need a t to like
precision determined by t.
actually that's a progress.
Progress. Oh yeah,
because
actually, yeah.
precision
progress.
is like 1 divided by whatever you need.
Yeah,
but then the
okay.
progress is
t.
whichever point you're drawing. Yeah.
Makes sense.
So so it's a recursive procedure. So if we
ding 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 ding, the magic word has just come out. Everybody, we're playing drinking game. The word has come out. Recursive.
Yeah. So if we reach our final point already, which means we reach the only one point that's left, we draw that curve. We know that point is on the
actual
curve.
point.
Yeah, the actual curve, the actual point on the curve. Otherwise, we're not there.
It's just a can of
we're not there yet. So what we do is we try to calculate the next generation of points from the previous generation, and every generation, if you remember, we are losing 1 point. Therefore, our new generation of point, the array will be one size smaller.
The previous one.
And then we try to fill all those points. And how do we fill those? This is exactly what we just did. We take each point and its next point, and we multiply the first point by 1 minus t, and then we multiply the second point by
t.
By t. And then those are our coordinates. We're assuming we're in 2-dimensional world. This is our screen, but this can also go up to more dimensions. Like if we're doing something in the augmented reality or 3D coordinate, it's the same thing. Yeah, so after we populate the next generation of points, we will call the recursive procedure with the new points.
Take a drink now. If you're playing the recursion drinking game.
With the new points and then the same t. Yeah. So yeah, that's the pseudocode. After we understand what is going on, it shouldn't be too hard to. Can be implemented. So I happen to be a React developer, so I implement this with React. Okay, so I think
actually very good that there's no audience, because usually at this point, some people in the audience will just look at me very apologetically and say, sorry, you're talking about JavaScript. Like, it's not I don't like JavaScript, everybody. It's just I like CSS more, okay? Love is unlimited. Not a zero-sum game.
I think I need to close. I don't want to close all. Oh, okay, got it. Yeah, so let me just briefly explain this code. So I do have some UI implementation. So this first few lines, I created some controller basically to for you to add or remove control points. So you do click, then you add the control points. And
state management, everybody, state management.
And then once I get the control point, we can get the T functions by we can go into the useDraw curve later on, but how we get the T functions is by using the Rows algorithm, with calling them with the control points. We can query
keyword also.
Yeah.
Like ding 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 ding.
And then this is like curry, because if we go back to the
another magical word came out. Currying, everybody. Ding 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 ding. You all should be drunk by now.
Yeah, if we go back to the pseudocode, the second parameter is t, but I don't know t yet. So I want to partial evaluate this function with the points for now. And then, so after I get the t functions, I can determine a step size. It's like the threshold, how refined you want your curve to be. And yeah, for each of those i's, from 1 up until your step size, that's our progression. And then we want to push the final point, and we find the coordinate of the point by calling the t function. So the I divided by set size will be the t. And then after we populate this, we get all the points. And then for each of those points, we're going to draw the point. I call it point on curve. And
Good name.
Yeah. So that's how the code is structured. If we go into the use draw curve hook, we can ignore the left and right for now. So this one takes the array of points, and then it returns a function of t. So how it does that? This is exactly following the pseudocode provided by De Castillo. So if we're left with only 1 point, we return the point. And then otherwise, we will populate the new points. Yeah, and by doing what we just discussed. So these are the coordinates of the point. And then we return, once again, let's not worry about the left and right thing first. So we call draw curve again and call it with a new set of points and the same t. So this is, we've never, we did not try to be smart. We follow exactly the steps. So do you think it will work? Actually, you know it already.
Don't give any spoiler alert, ne.
Okay, so I think we should. So here, what you can do is you click, get like this curve. You can add, like,
magic.
You can add more curves, add more points.
Where's my air horn?
Yeah.
I have an air horn. Where's my phone?
Use a keyboard.
Yeah.
Oh really? No, this one not shock.
Okay.
Not shock. Wait, I have an air horn. Everybody, take a break. Let your mind, let this simmer in your mind. Wow, I locate my 5-year-old air horn.
Does it still work?
You should my audio 没有 deprecate 吧? Cannot be. Sound board. I hope I remember my own URL correctly.
Oh.
So angry. Air horn, everybody.
Amazing.
Later must share. Good thing must share people so people can just click. They don't need to know the message. Like click. Today my boss very annoying.
Yes,
Click. Wow, today my boss made me do X. Click.
Yeah, I
it's
think
fun.
well, actually there is a clear, but I think I did like this the other day, and then I'm like, yeah. So,
Oh wait, you cannot do a spiral. Ha.
Actually you can. I forgot how I clicked the other one.
You think it's a specific pattern of clicking. You can go figure out on your own. Everybody, we'll share the link to the code sandbox later. Shout out code sandbox. Amazing.
It's quite amusing. But I also get bored like after a night of clicking. You can't do it too much. Yeah. So
ideally, you don't want your boss to piss you off every day. What? Like, why today?
Yeah.
Every day also. Then that means you should probably you don't get a new boss. Moving on.
Yeah. So yeah, that's the implementation. And next, I want to talk about a few properties of Bezier curves. That one is also quite interesting. So the first one is, well, it sounds trivial, but there is implications after that. So the whole curve will always stay within the polygon that encloses, that defines it. So what that means is the math term is called convex hull. It's a bit scary, but basically it means if you take a thread and you go around like all of these points, right? and then the final polygon you will get is called the convex hull. So basically, the property says your final curve will not go beyond this, like
the bounds of the original polygon.
Yeah. So the actual so this means you will be guaranteed to have a bounding box. Bounding box is something we're more familiar with. It is not necessarily the actual the convex hull, but you have an algorithm, a constructive way of finding the bounding box also. But you are guaranteed that your curve will stay
within the bounds of your box.
Yeah, so that's the first one. And then the second one, you can, if you have a very large curve, you can break the curve into smaller pieces by the T. And each of the segments is still a Bezier curve. So that's, it sounds amazing, but after you think about it, right? Once we have this T, it's a progression. But what if I decide to walk up until this point and never walk again? So this point can be regarded as the end point of the journey that I have already walked, but the starting point of the journey that I have not yet walked. So that T separates the original Bezier curve into two Bezier curves. And then what's even more convenient is that the control points are already computed. So yeah, so we can see from here. I think we probably won't justify this. If you are interested, you can read some math text to see the proof. It's actually it's non-trivial, but we can see from here that the control polygon, the control points of the first curve will be the first the first point of the first generation, and then similarly the second, the other side is also so this one is rather simplified, but if you have like more control points initially, the set of control points you get is so this is the final point, the yellow one, and then the previous control point will be the last control point of the previous generation, and then the last control point of the previous generation. Yeah, so with a bit of logging, we can actually also have all the control points of the first segment as well as the second segment. So this is what the left and right thing that I just talked about. And you have a similar pseudocode as well, and you can check out the code. I think today I won't go into the detail how to do the left and right thing, but basically this is how you can actually draw the two smaller segments of the curve without even computing any more control points. Yeah, so I actually just talked about this already. Yeah. So
moving on with life.
Yeah, okay, so this is the pseudocode. We won't go into detail today. And then, with the two properties that we just talked about just now, right? It has like implications that I imagine my engineer friends will like. Basically, it means you can find the intersection of any two Bezier curves by continuously breaking down your initial Bezier curve. And then after you break them down, your two curves each will have smaller bounding box, and you can check whether your bounding box has overlap again. And so you reach the point where either your set of bounding boxes have no intersections at all, or you keep going and you still get intersection, and until at some point you reach pixel level. So you're drawing one single pixel and they're still overlapping. Then so mathematically, either they're actually not yet touched, but they're really close. They're just really near each other, but close to a point where you no longer care because you're at pixel level and people cannot tell the difference.
What's the term for a curve that reaches, like keeps getting closer but never touches? There's a name for it, right? You know?
Yeah, but I also cannot recall the name.
Yeah, okay.
Or you really have the
Found the
actual
intersection point.
Yeah. But then that's the engineer side of this. You have a threshold again. Once you pass that threshold, you still get the intersection of the bounding boxes. Then you just take it
acceptable approximation.
Yeah. then you get your acceptable intersection. What's this?
Check code. Is this a note to self?
Yeah. So, and it's not in the right order.
Bezier curves which are still not implemented in CSS. Everybody.
Yeah, this is the I think in the issue that you shared.
Yeah.
So basically you can join. It's not really joining. You're kind of connecting Bezier curves to form. This is no longer one Bezier curve, but they're like segments of Bezier curves.
As you can see, the name is not cubic Bezier, it becomes poly Bezier.
Yeah. So these are like
air horn.
Yeah, these are like multiple Bezier curves, like joining together. I think since I'm no longer drawing, let me stop sharing. Can I? Let me stop sharing here.
Do whatever, man.
Yeah, because I need the power of a laptop now. Yeah. So let me share from here.
Does it work?
Not
yet. Okay, I got sound effect for when it works.
Okay, let me
finger 准备好了. You can test the
actual. Does it work? Oh, nice. What's this?
Final Fantasy. It's called Victory. I got a lot more. We can discuss this soundboard later.
Okay. So you can join them to form poly Bezier curves. That's actually the sweet spot that we just talked about. So they look nice enough, and but then they also are backed by all the math behind the Bezier curves. So basically, here's how it happens, like intuitively. What you want to do is you want to match both the velocity and the direction of the two curves. So you can see from here, like these two segments are same length, and then they're pointing away from each other exactly 180 degrees. So what happens if they're not like that, right? So let's say like this. Maybe it becomes really short, but still roughly same direction. You can see that the point is moving much slower. Or if you get like this roughly the same length, but pointing at another direction, you also see like a sharp turn there.
Yeah.
So what you want to do is to make sure that the velocity matches at the joint. So this is why, like I think once you see this picture, right, so here it is a poly Bezier curve, and each connecting each other, and then based on the restriction that I just talked about, if we change something here, and this side will try to match that that segment. So this is why like it's kind of like everything is moving. But then if we use cubic Bezier curve, you can imagine if I change it here, only this segment will move, but this part won't. So this is how you can actually make some local changes, but without affecting the whole curve. So that's I believe that's part of the reason why they choose cubic Bezier curve, because you have this this nice property that goes around the globe, the non-localness. It's like a limitation of Bezier curve, but then you can keep connecting, and then to form a more rich curve that you might actually need.
At this point, I guess it will be more relevant for those of us who have to do graphics. So this is is the reason why I thought about the timing thing earlier because this is not really CSS. But it is very, very relevant for SVG because I don't know how many of you would hand draw your own sheet, but like I did have to hand draw my own sheet in a past life. And like clearly maths is not my strong suit. So what do? I use to measure my eyeballs to eyeball all the diagrams.
Oh yeah. You might actually enjoy this game. It's called Bezier game. So what you try to do is I think this is what a graphic designer.
So basically, if you use like Illustrator or Figma, Sketch, if you use the pen tool, this is basically the same interface.
I'm apparently like not good at this game.
Can practice one. Practice makes perfect.
Yeah. So limitations. One is like I mentioned, is not local. If you remember when we calculate
model shapes.
Typo.
Oh, model.
Yeah.
What is a model shape? I'm confused.
So
capital K. Confused.
Yeah. So anyway, non-localness talks about how if you recall how we calculate a point on a curve. We actually so at every segment takes part in it.
Yeah.
So once we change the t, like at every segment we're using a new t.
Everybody gets affected.
Yeah. So in a Bezier curve, changing one control point will change your
the whole
curve.
shape. Yeah.
Sometimes if you have very high order curve, it might not seem that obvious, but it's actually changing the whole curve. So that's non-localness.
Yeah.
So that's why so there is more advanced math technique for that. Basically the spline thing that the poly Bezier curve is trying to handle, and then the connection. And then the other limitation is that you cannot precisely model circles or ellipses.
We will talk about this later.
That's also another like limitation of the Bezier curve. But once again, you will have the mathematical tool that you will have. Yeah, Bezier curves in browsers. So yeah, this is not a
This
CSS
is your
one.
big attempt to try to link it back to CSS. Don't worry, we already covered that for you. So Beaki is okay.
Yeah, it's if you look beyond CSS, CSS, the timing functions, I think, okay, it's oversimplification to visualize it directly as the parabola throwing things, because what it really does is it's kind of twisting your time, because it's timing function.
It is modeling the speed at which your whatever you want to animate.
Yeah. So yeah, CSS definitely one use case in our work. And then SVG paths,
which we also already talked about already.
Oh yeah. So in SVG, if we draw a path, the SVG command goes like there is an M, which means move to, and then L means. Okay, I think I'm not explaining this like properly. So
while you scroll, okay, you're there. I was gonna say something about SVG, but never mind. You finish first.
Yeah. So the path is, you define path this way. The letter M means move, so you move to 100, 100 coordinate, and then L means line. So from 100, 100, you draw a line to 300 and 100, and then you draw a line again to 200, 300. And then Z means you close the curve. But then you don't have, you might want to draw a curve instead of the straight line. And so that's the cubic Bezier curve commands come from. It's a C, and then S is slightly different. It means to use the previous endpoint as the first control point. And then so it's actually implemented in SVG already. And then you have two options. You have the cubic version. You also have the quadratic. Quadratic means 2.
Power 2.
Power 2, yeah.
Cubic power of 3,
Yeah,
everybody.
so
Just in case you forgot what your secondary school maths teacher told you.
Yeah. So basically, cubic means you have 3 control points, and then quadratic means you have 2. Yeah. What was the thing you wanted to talk about?
Oh, okay. Some people who you are in the data visualization space or web development, shout out Shirley Wu, who showed up. We managed to get her for JSConf Asia in 18. She's actually quite if you do data visualization, you'll know who she is, Shirley Wu, and she draws her SVGs by hand. Based on, because now you already know the secret. She already explained to you what the C, what the M, what the L is. You can actually, according to her lah, she is faster for her to draw by hand. But yes, SVGs, you don't really have to draw them by hand after you know this, but you can tweak because you know what number to tweak. Because I actually also tweak my SVGs by hand, but I don't draw them by hand. I just tweak the numbers by hand. Yeah.
So yeah, basically cubic Bezier Curve already
Practical
implemented,
applications of cubic Bezier functions. Everybody.
Yeah, if you do not want to write the Castillo
Ding 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 ding.
by yourself, you already have the browser already does it for you.
Because you think you're very good at maths, but the browser can do maths better than you.
So it should not be surprising to you that Canvas has its counterpart. It's also
Canvas. I love my soundboard. I'm sorry. You have to.
So it says Bezier Curve 2. So it's also
because semantic naming is a thing, everybody.
So
yes, 这个就是我的中意的 topic.
So if we take a step even further, like this, of course, browser also render fonts, but then
this is a superset. Browser is a subset, but superset is graphics, rendering, everybody.
So a font glyph is defined like this. Once again, this is not a single Bezier curve, but it's more like
we have a font talk one of these days? Oh my god.
Actually, Tiger talked about this.
来，派你去 no hard shell.
I'll try. So a font is saved in the computer this way, and this is actually just a bunch of Bezier curves.
This is how PostScript works, everybody. PostScript.
Next slide, PostScript. So it's actually it's Bezier curve empowered programming language.
PostScript is the very first vector font released by Adobe. I can't remember a name because I've not given this talk in 2 years. But this is essentially what they use to
draw vectors. Use.
I think that this one a lot of the other font formats had come after this because the end you cannot raster fonts is just you can't you really cannot. So this was the first vector font that ever released commercially on the market, and I think Adobe made a bomb out of it seriously. But yes, fonts. Maybe we will have a fonts talk someday. Hint. No hard shell. Yes.
I hope he's watching. I don't know. His cat maybe watching. So that's the Bezier curve.
References will be shared with everybody in the newsletter that nobody subscribed. Actually, not true lah. According to Tiny Letter, I have 40 subscribers. I don't know if they open the mail or not, but I spam you every month anyway. So
I'm one of the 40.
Amazing. Actually, half of them are our own people. So sad, right? Okay, anyway. More references, everybody. Because one page is not enough.
Right.
Amazing. Okay. I still got one more appropriate sound.
Excellent.
I stole this from somewhere. If anybody can, I'll play again. If you can tell me where I stole this from, you won't get a prize lah. Maybe I give you a sticker and see your face. I played it twice, You all tell me where I got it from. Oh, there's another slide, Okay, thank you everybody. Please give virtual applause, wash hand, the wash hand. I why everybody want wash hand on YouTube. If you don't get the wash hand, what I'm talking about, never mind, you also go and figure it out.
You share screen. I only got. Okay, a bit long today, so I will cut short my announcement section. Section, share screen, desktop. You'd think I know how to do this. Hi, Chris. Anyway, this is tangentially relevant to Chris. Announcement skip because only I got announcement. RK happening Friday. I already said already. Venerable Sifu is going to be on, so everyone must tune in and subscribe. Subscribe to RK because we will go like we are 500 by end of the year. Moving on. Okay, so we are partnering with Web Directions Code. So as you see, Chris's head pop in and out. Everybody must please remember that Chris is now back in Australia, in Melbourne. So he will be involved in Web Directions Code, which is now a remote conference, and they have gone with a interesting format, whereby it's not just one-day conference; it is a weekly conference. Also, they have tried to structure it that optimize for Southeast Asian time zone. So as you can see, wow, thanks. September whole month, then 9 AM to 12:30. The discount code is SingaporeCSS, but according to the guy, his organizer, his name is John, right? He's saying he's trying to do a billing for SGD. So you hold off first. Remember that the discount code is SingaporeCSS. It's like $100 off. So I let y'all know first. I implant this idea in your brain. Like then y'all can mark your calendar first. Like if you want to go and pato, no. You bring the pato person to come and watch this conference with you. But anyway, I'll keep reminding everybody about this. Just let y'all know first. So yes, it's CV now. Phase 2. Y'all could have gone out to like I don't know, go and meet girlfriend, meet boyfriend, meet wife if the wife or husband never live with you. But y'all still chose to tune in. And we are very thankful that you continue to support the most anyhowly meetup in Singapore. Wash your hand, don't touch your face, don't touch any other people. Okay, thanks. Bye. We will see you next month if next month happens. All right. Cut. I don't have the YouTube window open because I was forced to close it. So like somebody please turn it off for me. Thanks.
Oh.
In the meantime,
Me?
yeah. The non-local won't get this.
What's this?
你应该有听过吧 We will explain to you later. Can you help me off